Here we have LeetCode problem 21, merge two sorted lists. So you're given the head of two sorted linked lists, list 1 and list 2. You would basically just want to merge them into one big list that contains all the nodes of list 1 and list 2, but you want to keep them in sorted order, as you can see in the example here. This is the output. It's 1, 1, 2, 3, 4, 4. So it has all the nodes of list 1, all the nodes of list 2, but you keep it in sorted order. Right? So if you don't know what a linked list is, it's simply a list where each node has a value. So in this case here, it has a value 1 and also has a pointer to the next node. This node has a value 2 and a pointer to the next node. This node has a value 4 and the pointer to the next node, which happens to be null because that's the end of the list, right? So that's quick and simple how linked lists work. If it's your first time hearing about linked lists, you should probably do some more research before jumping into this problem. But if you have a basic familiarity with linked lists, this should not be too difficult for you to solve. So essentially all we want to do is we want to compare, you want to loop through the lists, each node in list 1 as well as each node in list 2, and you want to compare the values. So for me, what I would do is I would say, okay, is this node here less than or equal to this node here? If it is, I would append this first node. So 1 is less than or equal to 1. So for my merge list, we'll just call it ML. I would append 1, and then I would iterate forward to the next node in the list that I had appended from. So now we can see this. Is 2 less than or equal to 1? No, so we append the first node of list 2. So then, of course, it has a pointer. It points to list, points to the next node. So we append 2, and then we iterate forward. Right? And we'd do this in a while loop, and I'll show you how to do that in the Java code later. And then now you do the same thing. Is 2 less than or equal to 3? It is. So you append it there. Then you move forward. So now our current node for list 1 is this node with the value 4. Then we say is 4 less than or equal to 3? No, it's not, so we append a node from list 2. And then we iterate forward. So now we're at 4, and 4 is 4 less than or equal to 4. It is, so we append that here. Right? And then this list 1 actually equals null. So this is the case. In this case, the while loop will stop because we're looping while list 1 is not equal to null and list 2 is not equal to null. So we iterated through list 1 to the point where list 1 is now equal to null. So the loop would break, and all we would do is we would check, okay, list 1 is null, so we would append the rest of list 2. The rest of list 2 is essentially just this value. It's just the 4. So if we append that to this crudely drawn merged list, we would do 4. Boom, and that's actually the correct output. So we just move through the list comparing each value to each other, and then we want to return the merged list. So we could actually have a dummy that points to the head node, because as we're looping through, we're actually going forward through the merge list. We're going here, changing that one. We're going here, changing that one. Going here, changing that one. So if we return merge list, we would actually just return this 4 here, this node here. But if we keep a dummy just sitting at the start of the list, we can just return the dummy. And that's the correct way to solve this problem in O of n time. So, and you don't really use any data structures besides a list node, which is what will be returned at the end. So I'll show you how to do it in code right now. Okay, so here we have the LeetCode problem, and the first thing you want to do before you do anything, before you create a new list node, before you do anything, you just want to think about some edge cases. So the edge case where both lists are null, you just return null, right? Or one list is null and one list is a value, you just return the second list that has the value. So how can we take care of these edge cases that are actually given as examples? We can just simply do if list1 is equal to null, all we do is return list2. If list2 equal to null, we return list1. And that would take care of both of these edge cases immediately. Okay, so now, as I said earlier, we want to return a merged list. So we can go ahead and declare that, we can declare and initialize that merged list. So as you can see given in the comment here, it's a definition, so it's a list node. So all we do is create a new list node. So list node merged list equal new list node. And then we want to pass in the value -1 for the head of the node, because the head of the node will just be a placeholder and it will not be part of the given solution. So we're just using that -1 as a placeholder. And then we want to create a dummy that just holds the spot of the head of the list node. So we can call it dummy. We can make it equal to merged list. And that's as simple as that. This dummy will always hold the head, which is -1 at this point, and then in the end we can just return dummy.next, which will be the very first node of the merged list. And that's what will be returned, dummy.next. So now, as I said, we want to loop through each list while list1 is not equal to null and list2 is not equal to null. And essentially, if we finish dealing with one list before the other, one list becomes null and then another list still has values, we'll just append those values at the end outside of the while loop, which I'll show you soon. So now, as I said in the explanation, you want to compare node to node. So it would be like this: if list1.val is less than or equal to list2.val, we want to do merged list.next is equal to list1, because we want to make it equal to the value that's less, since we're trying to get it in order of least to most. And then we want to push our merged list forward, so then we can deal with the correct node. We can append at the correct place. So merged list equals merged list.next. And then we also want to push list1 forward, because we already appended from list1. So we don't need to deal with that node anymore. So list1 equal list1.next. And then it's as simple as that. And then we just need to deal with the case where list2 is actually less than list1. So you can just do else. Then you can copy this, paste it here, and then just change it. Merge list equals merge list.next is equal to list2. Merge list is equal to merge list.next. That stays the same. And then list2 is equal. We want to push list2 forward because we appended from list2. And if I'm not mistaken, this while loop should be fine. And then now we reach the point where we want to find out, okay, which list still has values, which list is not null, and then add the rest of that list that's not null to the merged list. And since it's sorted, that will work out completely fine. So if list1 is equal to null, we do merged list.next is equal to list2, right? Since list1 is null, list2 has stuff remaining, so you just make merge list.next equal list2. Then if list2 is equal to null, merge list.next is equal to list1, right? And now dummy has been holding the head of the list, which is -1, but we want the real head of the merged list, since -1 is just placeholder nonsense. We don't really need that. So what do? We return dummy.next. And let's see if this works, if I have any syntax errors or if I did anything wrong. We can run it. Okay, looks good. Let's just submit. Again, this solution is O of n, where n is equal to the amount of the sum of the nodes in list 1 and list 2, because you're looping through all the nodes within list 1 plus list 2. So yep, that's the solution for you. And if it's helped, feel free to subscribe or comment or anything. So thanks for watching.